I'm going to go ahead and jump down to 63. They change our equations a little bit and they give us these two, y equals x squared and y equals 2x minus 5. We can take a moment to graph both of those. Kind of talked through the first one, so I'm not too worried about showing it again. And whenever we show these graphs, we get the following image. Dum, ba-dum, bum, bum. Boom. Now this one's a little bit different because when we're looking at this one, it looks like they don't cross. And you might be saying, well, what if it changes later on in the graph and you're not 100% sure? An easy way to see more of the graph, if you go to the zoom button right in the middle, click it. If you notice down here it says zoom out, you click that, it automatically zooms you out. I believe now we're at 20 by 20 or 40 by 40, something like that. Now when we do this, we see that clearly our parabola keeps going up and staying near the y-axis, whereas our line is slanted over, so clearly there's no shot of them coming back together. And this is important because sometimes we're going to have graphs that don't have intersections, and you may be wondering, well, algebraically, how do we know what happens? Well, as we addressed earlier in the review of yesterday's problem, this one, if I were to solve by hand, I would come over here, okay, and I would start by saying that if you consider my two functions, so my first one was f of x is equal to x squared, and my second one, I guess they were both y's, be consistent, so I've got y equals x squared and y equals 2x minus 5. Well, since y equals y, I can write, based on substitution, that x squared must equal 2x minus 5. Okay? So if I take advantage of this statement and I want to solve for x squared, a quadratic, what I need to do next is I need to get everything to one side. So I'm going to subtract my 2x and add my 5, and I get that x squared minus 2x plus 5 is equal to 0. If I think about factoring this for a second, I'm asking for two numbers that multiply to 5 and add to a negative 2. And last I checked, my only options to multiply to a positive 5 are either 1 and 5 or negative 1 and negative 5. And there's no shot of adding those to get to negative 2. So in other words, we get an equation that's not factorable. There is no solution. There is no point for which these two graphs cross. Salutation. Wow, I got really distracted while I was writing that. I even put a parentheses instead of quotes. I'm going to leave that just for fun, because you guys can have a little bit of fun with that. Obviously, I should have written, quote, no solution, end quote. Yeah, so there's a little fun. So if you actually chose to watch this, hopefully got a chuckle out of that, because apparently I was distracted. Who knew? But anyways, there's that first part.